Andrew Wiles by Lauren Bruce, Crystal Wilson, and Ian Colwell.
Hey Math 187, our presentation is on Sir Andrew John Wiles. So, Mr. Wiles was born on the 11th of April 1953 in Cambridge, England. That means he's 65 years old and he's still alive today. His father was a professor of divinity, so he's always had an academic background, and even from the age of 10 he was fascinated by Fermat's last theorem, which will be talked about a lot later on in the presentation. Wiles studied a Bachelor of Mathematics at Oxford University, graduating in 1974. He then went on to do a PhD at Cambridge University, finishing that in 1980. While at Cambridge, his doctoral advisor was John Coates, who he later worked with on the arithmetic of elliptical curves with complex multiplication. He also worked with Barry Mazur and came up with the generalization of a principal conjecture of the Iwasawa theory, the result being totally real fields. He also has won lots of awards in mathematics, including the Fermat Prize in 1995, the Shaw Prize in 2005, and the Abel Prize in 2016. He was also knighted in the year 2000 for his contribution to mathematics.
Contribution to mathematics. Andrew Wiles's proof is extremely important. It led to an enormous program in number theory, the Lagrange program. Proving Fermat's last theorem also proved much of the modularity theorem and opened up entire new approaches to numerous other problems and mathematically powerful modularity lifting techniques. Fermat's last theorem states that no three A, B, C satisfy the equation A plus B equals C for any integer value of n greater than 2. This statement is very simple and can be understood by anyone who has a basic knowledge of mathematics. However, although this theorem seems to be very simple, its proof is not, which is why it has become so popular. For more than 6 years, he spent all the time he had available for research on Fermat's last theorem. He was also very cautious to not let anyone else know what he was doing. He only told his wife the details of his research. To cover his tracks, he intermittently released carefully chosen snippets of his earlier work. Did he have to overcome obstacles to have his work accepted? Not really, but he had to overcome the fact that it went unsolved for 365 years and had a large number of incorrect proofs. FLT, Fermat's last theorem, also had a large amount of public pressure, so there was some pressure on Wiles due to this. One of the obstacles he had to overcome was realizing that he did not have sufficient mathematical knowledge, since he was 10 years old, to solve the problem. So he came back to it 10 years later when he did have enough knowledge. When Wiles first released his proof to the public, they discovered a flaw in his reasoning, and for more than a year he was unable to make the necessary adjustments that would save his proof. He has admitted that he was close to abandoning the proof in September of 1994. However, he finally realized how to get around the flaw in the original paper.
Fermat's last theorem was regarded as one of the greatest mathematical puzzles due to the fact that it had gone 358 years unsolved. The proof of Fermat's last theorem then proved much of the modularity theorem and opened up entirely new approaches to numerous other problems, including mathematically powerful modularity lifting techniques. The work of many scientists, particularly in the field of physics, has benefited greatly from Wiles's proof. He created new directions in mathematics which had a huge effect on the broader scope of mathematics and science. The proof of Fermat's theorem itself is perhaps not altogether important. However, in the many years that went into Wiles's proof, he strengthened the development of algebraic geometry and algebraic number theory. Wiles's work proved a seemingly simple problem through very complex mathematics. Mathematical theorems surrounding modularity and the algebraic geometry today build on much of Andrew Wiles's work in many different ways. The modularity theory and its relationship with elliptic curves is constantly being extended and deepened by mathematicians. This is an integral part of all number theory and is important in the work of many pure mathematicians and their work today.